Welcome to Cosmic Compass, where we explore the wonders of space and uncover the mysteries of the universe. Today, let's journey together to the realm of Jupiter, a planet so massive it could fit more than 300 Earths inside it. 3 years ago, NASA's Juno spacecraft arrived at this giant world. Since then, it has flown closer than any spacecraft before braving Jupiter's immense radiation and capturing data that has reshaped everything we thought we knew about the planet. What has Juno discovered so far? What secrets has it revealed about Jupiter's storms, its interior, and its powerful magnetic field? And how do these findings change the way we see giant planets across the cosmos? Let's find out. It's hard to believe how quickly time has passed, but Juno has now spent 3 years orbiting Jupiter. During this time, the spacecraft has flown closer to the gas giant than any mission before sending back data that has transformed our understanding of the largest planet in our solar system. Juno has just completed its 21st orbit out of a planned 35. That means we are well past the halfway point of its mission. Some of you may recall earlier updates about Juno, but today, let's dive deeper. What has it revealed so far, and have its discoveries overturned what scientists once assumed about Jupiter? Before Juno arrived, many scientists were uncertain whether it would even last this long. Jupiter is surrounded by intense radiation-energized particles trapped by the planet's immense magnetic field. Juno follows a polar orbit, coming within just 4,000 kilometers of Jupiter's upper atmosphere. This path allows it to avoid much of the harsh plasma environment, though not all. Early on, Juno surprised researchers by showing that the radiation in its orbit was weaker than expected. This meant even its camera, initially thought to be one of the first instruments to fail, remained operational. Yet Juno also revealed something unexpected: a small but powerful radiation belt tightly hugging Jupiter's equator. Its cause is still a mystery. Despite the spacecraft's resilience, every new orbit gradually takes it deeper into Jupiter's main radiation belt. Mission controllers know Juno cannot last forever, and when the time comes, they will intentionally crash it into Jupiter to prevent any chance of contaminating the icy moon Europa. Radiation around Jupiter is not just a product of the planet itself. Much of it comes from Io, the most volcanically active body in the solar system. Imagine a moon so violent that it ejects a ton of particles into orbit every second. These particles form part of Jupiter's plasma torus, an invisible ring of energized matter circling the planet. As Io moves through this plasma torus, it interacts with Jupiter's magnetic field, creating what is known as a flux tube. This is essentially a colossal electric current linking Io and Jupiter with voltages up to 400,000 and currents in the millions of amps. To put it into perspective, that's millions of times stronger than a lightning strike on Earth. During its 12th orbit, Juno actually passed through this flux tube. It survived the encounter as the current is spread across a vast region, but the data it collected was among the most accurate ever recorded of such a phenomenon. Juno itself is an extraordinary spacecraft. At 20 meters across, it is powered entirely by solar panels, but at Jupiter's distance, sunlight is just 4% as strong as it is at Earth. Even with its vast solar arrays, Juno generates only about 400 watts, barely enough to power a small household appliance. Its spinning design is more than aesthetic. By rotating, Juno stabilizes itself and sweeps its instruments in wide arcs, making it perfect for measuring fields and particles. At the tip of one solar panel lies its magnetometer, an instrument dedicated to mapping Jupiter's magnetic field with unprecedented precision. Thanks to Juno, we now have the most detailed magnetic map of Jupiter ever created. The data revealed something remarkable, a concentrated anomaly scientists have named the Great Blue Spot. Even more intriguing, Jupiter's magnetic field is changing gradually over time, a process known as secular variation, something never before observed in a planet beyond Earth. Jupiter's powerful magnetic field also fuels the brightest auroras in the solar system. While Earth's auroras glow green and red to the human eye, Jupiter's shine in ultraviolet light with a radiant power of 100 terawatts. These auroras differ from Earth's in another way. They are largely powered not by steady direct currents, but by alternating ones likely produced by turbulence within Jupiter's magnetic field. At the North Pole, the aurora appears scattered and filament-like, while at the South Pole, where the field is smoother, it forms a more circular pattern. Look closely and you'll notice bright spots embedded within the auroras. These mark where flux tubes from Io Europa and Ganymede connect with Jupiter. Io's footprint is the most dramatic, but even the other large moons leave visible traces of their electric link with the planet. One of Juno's primary goals is to study Jupiter's interior, and here the spacecraft has upended long-standing theories. Scientists once pictured Jupiter as having a solid core surrounded by a metallic hydrogen layer and topped by a relatively shallow atmosphere. But Juno's measurements tell a different story. Its atmosphere extends thousands of kilometers deep. Beneath lies an immense ocean of metallic hydrogen stretching all the way toward the center. If a solid core exists, it is diffuse blending into the metallic hydrogen rather than forming a clear boundary. This metallic hydrogen is not something we can reproduce on Earth. It requires pressures millions of times greater than at sea level. In this strange state, hydrogen atoms break apart, allowing their charges to move freely and conduct electricity. It is here that Jupiter's dynamo originates, generating the enormous magnetic field that dominates the planet. Add to this Jupiter's rapid rotation, a day lasts just 10 hours, and the result is one of the most powerful magnetic dynamos in the solar system. Let's move upward again to the visible face of Jupiter, its clouds and storms. Juno has shown us that the cloud layer we see primarily composed of ammonia is more complex than expected. Fresh clouds appear bright white, while older ones take on a reddish hue after long exposure to ultraviolet light. At the poles where sunlight struggles to reach, the clouds look bluer. Among these patterns, Juno spotted towering pop-up clouds, perhaps the seeds of thunderstorms. Indeed, the spacecraft has detected lightning on Jupiter, though interestingly these storms occur more often near the poles than at the equator. And then of course there is the Great Red Spot. Juno flew directly over this iconic storm, revealing that it extends far deeper than anyone imagined, more than 350 kilometers beneath the cloud tops. Above 80 kilometers, it is cooler than its surroundings, but deeper down it becomes warmer, hinting at the forces that may drive its longevity. At the poles, Juno discovered massive vortexes unlike anything on Earth. Saturn has a famous hexagonal storm at its north pole, but Jupiter boasts 5 giant storms arranged around its south pole and 8 at the north. These appear to have remained stable for years, possibly centuries. Beneath the ammonia clouds, scientists believe another layer may exist, one of water ice. Juno is equipped with microwave instruments designed to detect this elusive feature. By searching for places where Jupiter's microwave emissions are absorbed, Juno could identify water-rich regions. So far, results are inconclusive, but the quest continues. Even at this stage, Juno has already reshaped our view of Jupiter. No longer do we picture it as a simple gas giant with neat internal layers. Instead, it is a dynamic world with a vast liquid interior, powerful magnetic anomalies, and atmospheric mysteries still unsolved. And as Juno's mission continues, the data it collects will help us understand not just Jupiter, but the history of our solar system. After all, Jupiter is the largest planet, and its formation shaped the destinies of all the worlds around it. By studying it, we also learn about giant planets orbiting other stars. Juno still has many orbits left to complete. Each one peels back another layer of Jupiter's secrets. And who knows, perhaps the spacecraft will surprise us again before its journey ends. For now, we can marvel at what has already been revealed, A planet once thought to be well understood has proven more complex, more dynamic, and more mysterious than we ever imagined. Juno's mission is still unfolding, and with each orbit, we gain a clearer picture of Jupiter's true nature. The discoveries we've covered today are only part of the story. The data will continue to be studied for years to come, helping us not only understand Jupiter, but also the very origins of our solar system. Thank you for joining us on this journey across the gas giant. If you enjoyed this exploration, consider subscribing to Cosmic Compass for more stories from the universe. Your support helps us keep traveling deeper into the cosmos, one discovery at a time. Until next time, let's keep looking up, looking